Our essential question for this video is, how do I graph a vertex form quadratic? We've already gone through the steps for graphing a standard form quadratic. You're going to find the vertex form is a little bit easier. It's nice to have a quadratic in vertex form because, remember, the first thing you do is find the vertex, and the vertex is very obvious when the quadratic is in vertex form. So write your essential question and then write the vertex form of a quadratic. Y equals a times parentheses x minus h, close parentheses squared, plus k. Here are your steps. Number 1, identify the vertex with h and k. That's easy enough. Now look how familiar this is. Put the vertex in row 3 of the table. Fill in the x column with 2 values below the vertex and 2 values above. Calculate the y values of the table. Plot the 5 points and connect them to form a parabola. If it's not a parabola, find your mistakes. Class, just to clarify that, if you end up finding points in a table and your shape looks like this, please don't graph it that way and just say good enough. Okay, that's not a parabola. Same thing here. If it goes like this and then all of a sudden it goes like this, trust me, you've got a mistake in your math. Use the graph to see your mistake and fix it. Alright, let's go ahead and follow these steps and see how it goes. Here's our function, f of x equals 1/2 times x minus 3 squared minus 1. Step number 1 was identify the vertex with h and k. Well, here's our h value. Here's our k value. So in this case, h is equal to, now remember when you pull out the h, the minus sign is part of the equation. Take a look. You can see it's x minus h. That means when you pull out h, you have to flip the sign. So in this case, h is 3. And the k value, since the the vertex form quadratic has a plus in there, then the sign doesn't change. Whatever the sign is in the equation, that's the sign of k. Now by finding h and k, here's the cool part. There's your vertex. So we've already figured out our vertex, no negative b over 2a like we do for standard form. Alright, let's go 2 numbers below. Let me change the color here. Let's go 2 numbers below and 2 numbers above. I'll go ahead and do one of these with you. Let's plug in 1. So we're going to go ahead and plug 1 in. So we're going to have, remember, whenever we do a fraction in the calculator, we put it in parentheses so the calculator knows, those 2 numbers go together as a fraction. 1/2 times, now, we've got x minus 3. We're going to plug 1 in. Remember I told you that whenever you plug a variable in, you always put it in parentheses. Now you can do that here, but since this x is already in parentheses, we should be okay just putting in 1 minus 3 and closing the parentheses. If you put in parenthesis 1, parenthesis minus 3, parenthesis, if you got double parentheses, it's not going to hurt anything. It's just going to make a little more work. There's 1 minus 3 squared, and then we have, remember, that's minus 1, not negative. It's not a negative sign on the 1. We're subtracting 1, so minus 1, and press equals, and we get positive 1. You plug 2 into that, you're going to end up getting negative 0.5. You should be practicing this with your calculator. Don't just be lazy and write the numbers down. Put them in your calculator so you can verify you know how to do it. When you plug in 4, you're also going to get negative 0.5. When you plug in 5, you're also going to get 1. Let's go ahead and graph these. Our vertex is 3, negative 1. 2, negative 0.5. 1, 1. 4, negative 0.5. And 5, 1. Again, look at that shape, class. It looks like a parabola to me. I'm going to try to make a parabola a little different. Let me see if I can actually accomplish this. I've been practicing this. Let's see if I can get something to look like a parabola here. That's not what I want anyway. Let's try again. It'll make my parabolas look a little bit nicer on my graphs. That's close enough. Not perfect, but you get the idea. Let's put arrows on it. There's our parabola. Let's see. Let's go ahead and figure out all the other values. Axis of symmetry, remember, axis of symmetry is going to be x equals, and it's the x value of our vertex. That's because our axis of symmetry goes right through the vertex, which happens to be at x equals 3. Our domain is always going to be all real numbers. Our range is going to be y, and then we're going to put our y value of our vertex, and since this parabola faces up, it's going to be all our y values on our y-axis are -1 or greater. So y is going to be greater than or equal to -1. And then is this a stretch or a compress? Well, we can take a look at it. Our a value, I'm going to write it here, our a value is equal to 1/2. When the a value is less than 1, we are squishing the graph down or compressing it. So let me scroll up a little bit. And this is going to be compression. All right, let's do another one. Here we go. F of x is equal to x plus 1 squared. All right, let's identify h and k. Our h value is right here. Remember, with h, we flip the sign because the equation for vertex form has a minus sign in it. That means the h value is the opposite value of that. This is going to be -1. Here's a little bit tricky. What's the k value? Well, there is no k value here. That means k must equal 0. And you know what? Let's just add this step right now. What's our a value? Our a value is right here in the front. Since there's no number, that must be 1. It's not 0, because 0 will change everything in this equation to 0. If there's no number and it's a multiplication, that means the number has to be 1, because that doesn't change the equation at all. 1 times anything just gives you that same thing back. Okay, what's our vertex? So our vertex is just h and k, -1, 0. Okay, axis of symmetry. Now let's figure that out in a moment. Let's fill out our table. We've got our vertex of -1, 0. We're going to go 2 numbers below that, 2 numbers above that. Let's go ahead and do one of these in the calculator right now. We'll do -3. So I'm going to plug in. I can put a 1 here, but I don't need to. We got a parenthesis. Negative, so that's the plus minus key, -3 plus 1, oops, forgot the 1, plus 1, close parentheses, squared. There is no k value, press equal, and we've got, you know what, something doesn't seem right there. Nope, it's right, it's 4. So plugging in -3, did I plug in -3? Hang on a sec. Now I don't remember what number I put in there. Let me see if it lets me go back. Nope. So I'm going to do it one more time, class, just to make sure. You know what? But now that I think about this, I did put -3 in there. I just realized what I had done. So we're good. So the answer for -3 is 4. If I plug in -2, try it yourself. You'll get 1. 0, you'll get 1. And 1, you'll get 4. Let's plot those points. -1, 0. Let's make that red. -1, 0 is our vertex. -2, 1. -3, 1, 2, 3, 4. And we got 0, 1. And 1, 1, 1, 2, 3, 4. There we go. That definitely looks like a parabola to me. Let's go ahead and try to draw a nice one here. I'm going to try my new method and see if it works. That's not terrible. Better than drawing it by hand. Put our arrows on the end. Looks like a good parabola. So I think we're good with our calculations. Let's identify the missing parts. Axis of symmetry is where the vertical line goes through the vertex, and that's at x equals -1. Or just make it simple and look at the x value of the vertex. Your domain is all real. Your range is going to be y, and let's take a look. Our y value of our vertex is 0. This parabola faces up. That means our y values have to be greater than or equal to 0. Greater than or equal to 0. And then last question is this stretched or compressed? Well, take a look at our a value. It's equal to 1. It's not stretched or compressed. You can say neither, or you can just say, hey, this is the shape of the parent graph. If I haven't talked about the parent graph yet, I will eventually do that, but just you can write here either this is the parent, or you can put neither. It's not stretched or compressed. It's the normal shape when a equals 1. All right. Last part of this video, another kind of question you might run into. The parent graph f of x equals x squared is shifted horizontally 4 units and vertically -7 units. What is the new function for the graph? Well, here's the thing. H and K are what tell you where the vertex is going to be. Okay? Now, if you look at this graph right here, H is 0 and K is 0. And you know on the parent graph, the vertex is at 0, 0. Okay? So for the parent graph or the parent function, it's at 0, 0. So now what's going to happen is it's telling us we're shifting horizontally 4 units. That means we're moving horizontal +4. So +4, we're going to go to the right 4. And vertically -7 units. -7 is down. I should write that the other way. -7 is going to be moving down 7 units. So what's happening is our vertex is moving to the right 4 units and down 7 units. Okay? That means our h value and our k value can be found with that information. Our k value is easy. If the graph's going down 7 units, our k value is -7, because that's going to be where we are going to be on the y-axis for our vertex. The h value, you got to be careful. Remember, we flipped the sign of h. So if we're moving +4 units, our h value is going to be +4, but it's going to flip the sign when we put it into our equation. So last thing we're going to do is, let's go ahead and write the vertex form of a quadratic. It's f of x is equal to a times x minus h squared plus k. Now notice I didn't write y equals a times x minus h. That's because it says what's the new function. They want us to write it in function form. All right, very good. Let's write it now. Well, f of x, that just stays the same. And our a value is going to be the same. It doesn't change. The a value doesn't determine where the vertex is. H and k determine that. So our a value is 1 here. Our a value is still 1 here. I don't have to write it, but I will. Okay? Our x value is part of our variables. And now, h is +4, so it shows up as -4 in our equation. And k is -7, and we keep that sign. And now what I can show you is we don't really have to write this 1 because the a is 1 and that's implied. We assume it's 1 if there's no a value written. And there is our new function. And I'll put a couple of notes for you here. Let's just show you this. A equals 1. This is h, which is equal to +4 because we flipped the sign. And this is k, which is -7. So it's actually not that difficult to do. If you know you're starting with the parent graph, and you shift horizontally 4 units, you can find the h value for that graph. And if you're going to shift up or down a certain number of units, you can find the k value. Then go ahead and just rewrite your equation. Let's put a square around that, or a rectangle around that, so we know there is our final answer. One more thing I want to do, go back to your previous answer here. I don't want to write parent here. I think it's going to be confusing. Let's just put on here stretched or compressed. It's neither one. I think that makes more sense. Because parent, we say parent, we're assuming it's the parent graph. So it's neither stretched nor compressed. It's the normal shape. All right, that's the end of the video.